Matt Wunch. Today we're going to be discussing geolocating models using drones. So let's kick it off. Next slide, please, sir. Community conversations provide opportunities for engineers, designers, and artists and makers to meet in a safe, live virtual setting, to share expertise, get to know leaders in your field, and grow your community network. The sessions are always supported by the Autodesk community managers to help guide the conversation, feed important insights back to the community, to Autodesk, and support participants in getting connected to the expertise you need. Next, the fun stuff, the rules. Just a few ground rules. Everybody's line is muted to reduce the background noise. We invite you to turn on your camera. It kind of fosters a physical meeting environment when we're in this digital space. If you have a question, raise your hand and the little reactions down in the bottom, or post in the chat, and we'll be pausing every so often for questions. If it's relevant and timely, I'll try and jump in and ask Matt if he could maybe address it. The sessions are recorded and the link will be emailed to everybody who participated. It'll also be on YouTube, so. All right, next, the lawyer statement. Just a quick a note, this is a safe harbor statement. If we make any forward-looking statements talking about future functionality, we ask that you don't make any purchase decisions based on that information, that you make your decisions on the product as the product is today. So it's a good thing, you know, if we promise it's going to have unicorns in it, we can't legally say there's going to be unicorns in it, although we could actually do it. All right, I'll introduce myself again. I'm Sean Hurley. I'm the engagement manager for Autodesk Community. I'm a longtime technologist. I've been with the company 24 years and in many different roles. Excited that you're here. I'm based in Bend, Oregon, and a little chilly. Matt.
Excellent. Yeah, thanks. So a senior technical specialist on the AEC side. Similar to Sean, you know, I guess you can kind of consider me a geeky technologist as well. You know, drones, lasers, AR, VR, XR, anything that you know, has to do with cool technology. It says based in Boston. Technically, I'm in Connecticut, but I guess Boston is the closest Autodesk office. So I've been with the company for a total of 13 months, so still kind of on the new side, but prior to that, 25 plus years experience as a CAD BIM technology manager. Some of you may know me from the Autodesk Expert Elite program. You know, I've been around on the forums, LinkedIn, Twitter, etc. So yeah, that is sort of me in a nutshell. So with that, you know, looking at the AEC collection, so this is what you have access to, and this slide is probably a little bit outdated. I don't believe Dynamo Studio is part of that anymore. But you know, looking at 24 plus different applications in total. But most people just kind of stick to their own little world, whether it's AutoCAD, Civil 3D, or Revit. What we're going to take a look at today is how you can take advantage of a little bit more of this. So starting off with the ReCap Photo, ReCap Pro, InfraWorks, Revit, Civil 3D, Format. Hopefully, if there's time, we'll dive into Navisworks as well. But really starting to leverage all these different applications to create that geolocated model, which is super important when it comes to making sure everything is in the right place where it needs to be in the world. So taking that Revit model, exporting it to use in Civil 3D, vice versa. You want to have those correct coordinates, correct points for you know, staking out columns out in the field, for example. So we're going to take a look at how we can utilize, you know, half a dozen or so of these applications. Real brief overview of the workflow. Kind of chunked it up into little bits here based on the applications that are being used. I'm not going to go too deep into this because we're going to see a lot of this stuff live, but just wanted to throw this in there so you do have access to. Are we sending out are they going to have access to the presentation as well, Sean?
We can make it available let's talk about that afterwards. We can put a
Okay.
link to it somewhere. We'll find a way to do that. It'll also be
Or yeah, or at least I can get the you know, like a snapshot of that workflow, just so they have that as sort of a reference. But you know, again, this will all be recorded, so you'll be able to actually, you know, go back and see all the different picks and clicks. So with that, I'm going to jump off video just to save on bandwidth here, because I do have quite a few applications open running in the background already. So taking a look at ReCap photo, right? So starting off with your drone photos. And before we dive too deep into this, I just want to point out that there are two different types of applications or projects that you can create with ReCap photo. There's the aerial, which is what we're going to be taking a look at, but there's also the object, and the object is really anything that isn't tied into a state plane coordinate system. So something like this statue, for example, or maybe a sign for an apartment complex or something like that. So not, you know, something that I guess really can be moved easily versus a building, which takes a lot more effort, obviously. But you know, typically something smaller like this would just be a project or an object project within ReCap photo. So let's dive right into it, right? So creating our aerial project is as simple, and I say simple because it really is, right? So we're just going to grab all of our photos. In this case, I have 470, I think, photos for this project. It's going to tell me how many cloud credits are required. I believe the new pricing is 3 credits per 50 photos. Don't quote me on that, but I'm pretty sure that's what it is these days. So right off the bat, we could certainly go ahead and upload these, create our project. But what I want to do is actually kind of make this, you know, a little bit more realistic, you know, tie it into the actual location a bit tighter, right? So I can specify my coordinate system. Right now, it's already set to Connecticut NAD 83. That's where this project is located. I have, where did I put it? I have an XML file that contains all of my points from a previous run through this project. So everything is green right now. So basically I've picked at least 4 points on these photos. And the great thing about these ground control points is it automatically filters out the images based on the metadata within the files themselves. So if we take a look at one of these photos, for example, scroll down, we see the lat long information there. So it's filtering out just the photos as it relates to these shots that were captured on site. All right, so this is going to make that mesh a lot tighter. It's going to make the point cloud tighter and really start to tie it down vertically with regards to the actual site. So once you get your ground control points set, it's just a matter of giving your project a name. I'm just going to call it test. We have the option now to upload directly to Autodesk docs, right? So I'm going to throw this up in not the field, but project files. I've got a drone flights. Yeah, so I would go through this process here. And what's going on here? All right, well, so we'll select this folder, right? I'm not actually going to go through this because I've already got it processed already, but you know, one of the outputs you get is that mesh file. So similar to what you just saw with that horse statue, you get that 3-dimensional mesh. You can also include the RCS, so the point cloud as well. Of course, we want that geo-TIF file. And if your drone has, if it captures that PPK or RTK information, that metadata in the photos, it can take advantage of that as well. And I really wish this would carry over that coordinate system, but in case it doesn't, we just select it there and we're good to go. Press start, it's going to upload all these files to the cloud, process them, create the output that you specified, and close this, cancel, yes. And what you're going to get, one of the files you'll see is this report. So it gives you a nice overview of your flight. So it shows you the entire area that was captured. You get a little elevation model as well. This image overlap is great because if you have some shots that for whatever reason, maybe the camera was out of focus or too much reflectivity based on water or glass or something like that, and the model just doesn't quite look right, you can get a good idea of what's going on with some of the overlap here in the elevation model as well. There's information about those ground control points that we saw earlier. So a nice little overview of what your project contains. Additionally, let me jump over to my cloud project. So I uploaded all this stuff to my construction cloud project. I've got that geo-TIF file. I've got the report that we just saw, the RCS file, the RCM, which is that mesh file. We've got two versions of the FBX. We've got one that's zipped, one that isn't. So just another version of sort of that mesh looking model. All right, so that is ReCap photo. And actually, let me just crack open this one. So this is that same, once it spins up here, this is that same flight. And I just happened to crop out all the ground from this model. And I'm going to actually use this a little bit later on in the presentation here, but really just kind of just stripping out the excess, we'll call it noise, right? So just wanted to be left with just the building itself. ReCap Pro, so we've got that same flight data, same model, but as we zoom into it, we can see that it's actually made up of millions and millions of points. I think there's upwards of 7.5 million, if not more, points from this flight. All right, so there's the start of our project, right? So thinking of a workflow where you go out to a site or you're working on a project and you don't actually have the job yet, right? So maybe you just want to grab that information real quick and get some sort of model in place. That's where you would start to do some of this reality capture. And jumping over to InfraWorks, right? So we want to take that information, we want to pull it into an InfraWorks model. So what we can do is fire up model builder, and it's basically a Bing Maps sort of interface. We can see the sort of the road type map, and then we can also look at it in a satellite image type of view, but very similar to navigating any other map. Left mouse button, pan around, the middle wheel will zoom in or out. We can specify an exact location if you happen to know it. In this case, I absolutely do know it, and there's that middle school that we were just looking at. So I want to capture this area. There's a couple ways you can do this. You can either do based on the current extent of this map. You can select a rectangle, and you can modify these grips. If I can just grab them, there we go. So you can make it larger, make it smaller. You can do a polygon if you want to do a sort of an unusual shape. You can also upload a shape file. So thinking of maybe the limits of a city block or a county, as long as it is less than 200 square kilometers. There we go. As long as the area that you're trying to capture is less than 200 square kilometers, you'll be able to create that model. All right, so that is the area that I want to capture. Now I've already done that just in the interest of time. So once you get that email notification or the tile pops up here, it says, hey, your model's ready to be downloaded. You can either save it locally or you could store it to the cloud. The great thing about storing it in that cloud project, be it BIM 360 or Autodesk Construction Cloud, you've got unlimited storage. So thinking about that first step of the drone flight, or if you're doing a laser scan, the terrestrial laser scan, if you've ever had to deal with those files, you know that they can be massive in size. So we're talking gigs and gigs and gigs worth of data. With the construction cloud or BIM 360, you've got unlimited data. So just store all that information up in the cloud. Don't worry about storing it on your local server, or even worse, maybe an external hard drive, which ends up getting passed around from one user to the next and ultimately locked in someone's desk as they go on vacation and nobody can access the data. That's actually happened to me on a few occasions. So nice little war story there. But being able to keep it all in the cloud, access it from anywhere, anytime as you need it. But this is the type of model you're going to get to start with InfraWorks Model Builder. Depending on where you are, you may have more or less information. In this case, it's sort of a little bit of a rural suburban type area. So not a ton of, actually really no building information whatsoever. But I do get information regarding the roadways. So it knows that this is Raffia Road. It knows that this is Post Office Road. It knows, all these different attributes associated with these objects. And you would get the same thing with major buildings, rivers as well, waterways. So all this is coming from OpenStreetMap's data. So we can actually see that just by right clicking or selecting on it. Where's that tooltip? There we go. And selecting the OpenStreetMap, and it's going to open up OpenStreetMap and show us exactly where that data source came from. Right, but we can augment all this with some of that data that we just created in the form of the drones, the point cloud, the mesh, and that's kind of what I've got here. So I've got a model that's a little bit more built out. We've got some of these apartments actually in place. We've got some additional information pulled in from a combination of ArcGIS online through the connector, individual shape files, but we want to pull in. Let's start with the those geo-TIFs, right? So going to our data sources, and we want to pull it in as raster because that's what they are. I've got those downloaded. Just again, in the interest of time and speed, I have them stored locally. And as it processes, there we go. Now, just because I imported it doesn't mean it knows exactly where it should be. So every time you pull in a data source, you must configure it. So basically telling InfraWorks, all right, you are this type of data source and this is where you're going to live. So it's automatically pulling that Connecticut NAD 83 coordinate system. So I can just hit close and refresh. And what we'll see once this spins up is those TIFF files right in this area. Now, just to give you a sense of how large these files are, we're looking at just south of a gig for these four tiles that make up this TIFF file. So again, another great reason to store all that data in the cloud. So once this finally loads up, again, a gig. So depending on the size of the data source, it may be quicker, maybe slower. But now we have an accurate, up-to-date view of that site. But you're saying, what is going on? Why do we see these sort of black holes where the drone didn't capture any data? Well, we can easily take care of that, right? So go back to configure, and under the color mask, just want to make sure black is selected. Click OK, close and refresh. And once this is done, this will basically be transparent. So while this is processing, any questions, anything that popped up in the chat there, Sean?
Yeah, we had a discussion on the limit of photos to process. And then Brian said that sometimes his teams are well above 1,000. And I kind of mentioned that, I've broken big projects up into segments, or sometimes we oversample the amount of photos needed for a given project. But what's your experience been on that?
So regarding the number of photos, I believe with the latest update of ReCap photo, it's up to 2,000. Yeah. I'd have to double check, but I'm pretty sure that's what I don't have.
I know we were 1,000 last year.
Correct. I could have sworn I saw something that said it's up to 2,000. I don't have the latest update installed, and this is ReCap Pro, so that doesn't help. Yeah, I'm pretty sure it's up to 2,000. I would have to double check. My gut is saying it's 2,000 right now. Yeah. Along with that change in number of cloud credits per, I think it was 50 photos. Every 50 photos is like three cloud credits. I should know this because I just did a ReCap webinar not too long ago, but I'm pretty sure that's what it is. So that new change in some of the photos and the number.
And I know I've oversampled before. I just set my drone to capture every 3 seconds, and realistically, I didn't need all that. We do have one more. Even though one stores files in the cloud, doesn't working with them require a temporary local copy be placed on the C drive, at least during the session?
So I'm assuming that's for, basically pulling those files into, say, Revit or InfraWorks, Civil 3D,
Right.
what have you. Yeah, so through desktop connector, it will cache those files. There is a setting, kind of getting a little bit off course here, but there's a setting in Revit, for example. Where is it? Just to make sure. Point
just
clouds.
pointing it out to make sure you have the available local storage if you pull down something big.
Yeah, so that's another thing to be aware of. Yeah, because of those cached copies of the files, the first thing I would recommend is certainly clearing out your temp folder, right? So easy way to do that is just the %, and then just delete anything that you can in this folder. So it's automatically going to bring you to the app data local temp. You can also free up space on the Autodesk docs or BIM 360. Whatever project you have there, you can free up some of the data there as well. Yes, definitely something to be aware of, though, I guess, with those cached files.
And thanks for that. And Nate confirmed that it is 2,000 is the new limit.
Is that Nate Philbrick?
It is.
All right. Yeah, we did that ReCap webinar not too long ago. Thanks, Nate. Appreciate that. Okay, so we've got that. Our geo-TIF pulled into InfraWorks, right? So now we want to pull in that model, that mesh of the building again. So we get better sense of where our where everything is with regards to the existing conditions. So I'm going to go to 3D model. And actually what I didn't show was that, through this process, I exported, once I trimmed out what I didn't want, I exported this to an FBX file. Save it wherever you want. You may want to mess around with the decimation just to, try to find a sweet spot between file size and visual clarity here. But something to take a look at. But again, I've already done this in the background prior to this. So let's jump back to InfraWorks and find our FBX file. There we go. And open. And again, we need to tell it what it is, because just because we bring it in, it doesn't know which of these data sources it needs to be. So it's going to be buildings. And we're going to say Connecticut NAD 83, because that's the coordinate system. Close and refresh. And give it a second to churn. See it populated over here. But where's our model, right? What I thought everything was tied into the coordinate system, right? That's what ReCap photo told us earlier. It's not underground, it's not hidden, it's not anywhere, right? So how do we get that model to show up where it's supposed to? Well, the key to that is, lost my spot here, go back to my project. In that FBX file, the FBX zip file, there is these two files. So we've got the result FBX and we have this result position file. We take a look at that position file, that's going to show us the exact coordinates of this model. So what I need to do, I'm just going to pull this off this onto the other monitor for now. Go back to InfraWorks and configure, and basically, take these. Get that dialog. There we go. Right. So basically, take this X, Y, and Z and transfer them over to InfraWorks here. So under the offset, I'll do that one, and I want to grab the next one here. Paste that. If I can copy paste correctly, there we go. Right, close and refresh. Now, if I got my numbers correct, that should pop right up in there. Come on. There we go. Perfect. Once it finally regenerates, there we go. All right. So now we've got that mesh model laying on top of our ground, within, context of the existing site here. Now I do want to modify my imagery. I want to pull this guy down a little bit just so I can see some of this other context that was thrown in here. Just a second to regenerate here. All right, so this is, sort of a preliminary layout, sketch, if you will, of an area where we want to throw in a little, maybe a COVID testing building, right? So we've got some cars queued up here. We want to design something that will fit in here. So in comes Civil 3D. So we're going to jump over here. And for this to actually work, I will just close InfraWorks altogether, because it kind of freaks out when you try to import an InfraWorks model when it's already open. So Civil 3D, and I just realized I have 21 open, but regardless, this will work with all the other versions. So everything else I'm running is the 22 version of Revit, InfraWorks, but that functionality does work in 21. Civil 3D 21 accessing an InfraWorks 22 model. So I am going to go out and grab my, in this case, it's my connected BIM 2022 SQLite file. And this is a brand new drawing in Civil 3D, never been touched, nothing's been done to it. And right off the bat, it says, hey, you don't have a coordinate system set. So let's click that. And yeah, let's use the one in InfraWorks. So that's going to set my coordinate system in Civil 3D to match that Connecticut NAD 83 coordinate system. So that's cool, right? Now we move further down. We want to specify an area of interest to pull in. So I'm going to do select an area because I rarely ever want to pull in the entire extent of the model. Now, if you don't have maps already set to show, you'll get a little pop-up that says, hey, do you want to use maps so you can actually see where you're selecting? You can just say yes and not show this again, and it'll automatically display the maps every time. All right, so this is the area that I want to pull in. I'm just going to do a little rectangle like this. Wait for this to churn up as it reads the model. Any second now. There's quite a bit of data in there, and it's just filtering through everything. But once that dialog box comes back up, we'll be able to refine which objects we bring in. So you can define basically like a selection set, if you will, of which elements you want to pull into Civil 3D. Great thing about this is you can base this all off of your company templates. So whatever your template is for surfaces, for alignments, for corridors, pipe networks, if that information resides in that InfraWorks model, it's going to be pulled across as these particular objects on your particular styles. So I'm just going to say, I'm going to go with all objects, rather small area and open model. And this should just take a moment or two to pull in this information. There we go. So it kind of zooms us out to the extent of that entire InfraWorks model, that area there. It's chugging through. I'm going to turn off the map for a second because I want to show you something that's pretty cool. So because I have some component roads in InfraWorks, it automatically recognizes those as assemblies. So brings them over as assemblies, as corridors in Civil 3D. So you don't have to mess around with recreating the wheel on any of this stuff. And you can see the little tooltip pops up. It knows Raffia Road, so it's pulling across all this information. So really reducing the amount of work that you would need to do. You can also see we've got a couple different surfaces here. We've got our existing, we've got our proposed. I did do a little bit of work on that InfraWorks model beforehand, but here's that existing. And one thing I didn't mention is that terrain that comes across in InfraWorks. That's USGS 10 or 30 meter data, so not super accurate, not super clean. You're not going to get those nice sharp breaks every time you see a retaining wall on a site. It's a lot more of a rolling interpolated terrain, but it's a great start. Here's sort of that modified surface that I had created. You can see a little bit more of a bank here around the school, which would have been in this area here, right? But the other thing we see is we've also got nice little sort of reference for where that site is, right? So we can see, this is where that little paved area was. This larger triangle here, that's where the grass is, and that's where we want to put our building, right? So we've got our civil 3D model. Let's actually save this so we can. How are we doing on time? I don't know if we're going to get to the Navisworks portion, but we'll see how we do. We'll just call this. Great, we'll just call this Convo. You can save this into your cloud project. In the interest of time, I'm just going to. I'm not even going to save it just because I want to make sure we get through a lot of this stuff. So what you can do now is save your project to your cloud, and then wrong tab, output, publish that surface. It's going to prompt me to save. Yes. All right. So I do have to save. All right. We'll just save it here. Cool.
Hey, Matt.
Yes.
Kate had a good idea. She said we can always turn this into a series too. So you don't need to stress about getting the Navis working. We can do that in the next one. So,
we can certainly do that. Absolutely. Yeah. Let's see how far we get today though, right?
Absolutely.
So publishing in the cloud, publishing that surface, you can select which of the surfaces you want. So depending on how many surfaces are in your project, you can toggle them on or off. I actually just pushed this proposed ground to my cloud project. So specify that output file. Where do you want that project or that file to reside within, in this case, Autodesk Docs. So you can drill down into your different hub, into your project, into the folder, wherever you want to store that. Again, I've already done that. So that's sort of step one in getting our Revit model in place here. So I'm going to try to show you two different ways of setting the coordinates in Revit. Let's go with the first one, which is we've got nothing modeled in Revit whatsoever. Brand new project, never been touched, never been, nothing's ever been done to it before. So in our, on the insert tab, we want to link the topo from that cloud project. And depending on the number of cloud projects you have or associated with, and the number of hubs, number of projects, this may take a little while to spin up. Plus, depending on your Wi-Fi connection, which is kind of lagging a little bit today. Just want to open this InfraWorks model back up while Revit is doing its thing over here. And we can close. We're done with ReCap Photo. We're done with ReCap Pro. Kick those to the curb. No, we don't want to save. Try to free up some resources here as much as possible. All right, so while Revit is thinking here, I apologize. This was much faster earlier when I was doing it by myself. Of course, I was also doing it at 10 o'clock at night. So any other questions? Anything else pop up in the chat there, Sean?
No, going along.
All right. This is killing me. It's nothing like a little slow dialogue box to throw a speed bump in your way.
It's probably somebody in your neighborhood watching cat videos.
Yeah, well, oh yeah, I got to shut those off on my phone over here streaming on the side. All right, so let's talk through this. So basically what you're going to see is a dialog box that pops up, and it's going to have access it's going to list all the hubs that you're associated with, and then you can drill down into each of those hubs, wherever that topography file is that you pushed from Civil 3D up to the cloud. Select that file, and it just comes in as a topo object in Revit. Now, in this case, because it's a brand new Revit project, never been worked on before, what you would do is acquire the coordinates of that topo object. And what you would see under the, this is really bugging me. I'm going to kill this thing. Revit. All right. Still just hanging out there in the background. All right. So what you would see under the Manage tab, you go to your site and location. After you acquire the coordinates of that linked topography, it's going to change from that typical dialog, typical interface, and it's going to show Connecticut NAD 83. So it knows exactly, it's got that same coordinate system. It's reading the same information. What is going on here? Oh, did it? All right. I guess it just needed to kill that. All right, so let's just kind of talk through it a little bit more, right? So you go into the location and site. This interface, this display will be gone. Instead, it'll say, Connecticut NAD 83. It'll show lat long. So right off the bat that it has actually acquired the coordinates of that site. From there, you can start to model your proposed building. Now that's sort of that's one way of acquiring the coordinates. And the reason I wanted to show that, or at least explain it in this case, is because prior to the 22 version, that shared reference point tool that we're going to take a look at next was not included with the install. So perfect example was 2021. So that dropped in, I believe it was late April, early May for Revit. And Civil 3D as well. That shared reference point extension tool download was not available until September. So if that was something that you were relying on using to set the location of your Revit model, you're pretty much out of luck, until that tool is available, unless you do the that other workflow of acquiring the coordinates of that published surface. But since we do have that shared reference point tool, again, we're in 22, so it installs automatically. So what we're going to do is we're going to actually utilize that, because that gives us it's a much easier way, honestly, of locating your files. So I've got this model here. I don't have anything set, right? So it's just, regular sort of out of the box stuff here. What I do have set up, sort of pre-baked, I've got this view set up that I would typically use, basically just showing walls, doors, windows, maybe some pads or something, maybe column grid lines, depending on the size of the file, that I would use to export to Civil 3D, right? So I'm going to take this file, I'm just going to export straight out to DWG. That's cool. So one thing you want to make sure of, actually jump back to this, your drawing units are the same. So Civil 3D, if you're in the US, typically it's feet. So just make sure that is set as well in Revit. Next, I'm going to drag this up on the other screen. So I've got my project here, drawings for Civil 3D. We'll just call this Civil 3D export. I don't want to include any XREFs. Cool. All right. So hopping over to Civil 3D. So this is where we want to locate that floor plan, right? So external references, attach that DWG, and we're not going to care about insertion points or specifying anything. We're just going to go specify on screen, because we want to actually kind of rotate this into place. All right, so I'm just going to do this real quick. And we'll throw it right there. Okay, cool. So we want our building to be somewhere in that vicinity, which again, is this pad area right here in our InfraWorks model. All right, so in comes the shared reference point tool, and it's not under add-ins, which you would probably think would be a logical place, but it's still sitting under toolbox on the tool space here. So under the subscription extension, if you remember the way back in the day, they were those extensions. It's still called that, and it's still buried under toolbox and not add-ins like everything else these days. But anyways, just right click on it, execute. It's going to prompt you for an origin point. And I'm going to pick this point here and then prompt you for a quasi north point. So I'm going to select this one here. Again, we want to make sure our units are consistent, right? So Revit's in feet, Civil 3Ds in feet.
Is that
InfraWorks
international feet or US feet? That was a question in there.
Let me back up. I don't believe it. I would have to find out. There's only one option for feet.
Yeah.
It's a good question. I'll dig into that and try to get that answer out to you guys. But regardless, feet. Okay. Yeah. So now it's going to prompt you to save an XML file. So it basically has those coordinates, that rotation angle. I'm just going to kick it under drawings for Civil 3D here. And cool. All right. So hop back over to Revit. On the add-ins tab, which totally makes sense where you would find that because it's an add-in. Import shared coordinates. So it's going to prompt you to pick that origin point. Now it's critical that you get those same pick points in the same order. One of the best ways of doing this is, especially if you're working with an outside civil engineer or an outside architect, and you want to make sure you're both talking the same pick points. If your model is larger, more complex, and actually has column grid lines, those are a great way of saying, okay, my first point was A1, my second point was B12, for example. So everyone knows the exact same pick points, regardless of whether you're working within the same office or outside your office with different consultants. So if not, just having that view set to the coarse level of detail, so you're not getting all of those individual wall layers, is also a big help in selecting, in this case, those outside corners. All right, so I want to select that one, and this one was my second point. So now it's prompting me, all right, go grab that XML file that you just created. Are you sure? Yes. All right. And nothing, right? So it didn't, why isn't it rotated like it is in Civil 3D? Well, just because we imported that XML file doesn't mean it actually did anything, right? So it's still, my internal site is still current. So I need to set this one, my new site. And it basically just pulled in the same name as that XML file. So if you had named it something a little bit more obvious than my shared ref point, it would pull, read that. So there we go. So it just flipped my drawing, my view. And again, so this is based on the true north, right? So if my view were still set to project north, after you go through this process and you're like, why isn't my building rotated? Well, just make sure your orientation is set to true north. All right, so there you go. So let's jump back to Civil 3D. Let's get rid of this guy, because remember, this one is just kind of placed in there arbitrarily. We just threw it in just to get a location for it within Revit. I'm going to save this now because I want to keep these changes in here. And file, export, CAD, DWG. Before you do anything, just make sure your coordinates and units are set to feet and you're using a shared coordinate system, because we now have Civil 3D and Revit sort of, air quotes, aligned with each other with regards to where in the world these are all supposed to fall.
Hey, Matt.
Yes, sir.
So Chuck said if he's using state plane US, it's survey feet. But we had a follow-up. It was topical to what you were just doing. Where does it put the survey point and the project base point? Was that your pick points?
All right, let me just kick this out to DWG here, and then we'll hop back. We'll take a look at turn off internal. All right, so survey point way down here, 0, 0, my ref point. Project base point way up here. All right, so hopefully that answers the question. So it is modifying the survey point, internal origin, and project base point are basically right on top of each other at the sort of this 0, 0, 0 of Revit. If that makes any sense. I know this whole subject in and of itself is can be overwhelming at times.
You're good, Matt. It answered it.
Understanding the difference between all the different points here. I will point out though, there was an AU class, and I think it was last year, that really explained this well and had a bunch of sample files within Revit. So as you moved the survey point or the project point, you can see how this sort of grid of of information would adjust based on that. Highly encourage you to search that one out. All right, so we've got our model exported to Civil 3D. And one thing I want to point out is, I think I mentioned this before, but I always like to create a unique drawing that has just those objects that I want to see kicked out to DWG, because unfortunately we can't read the Revit file. So we have to export to RV or DWG, but we don't need everything, right? We don't need to see all the furniture. We don't need to see all the all the faucets and the outlets and whatnot. So basically just strip it down to what is important. Is typically outside face of the wall, doors, any columns, or anything that may interfere with those entrance locations of the utilities coming into the building. All right, so back into Civil 3D, we've got our site here. We want to reference in our DWG file. There's my export 2 that I just created. Now, unlike the first go around, we don't want to specify anything. We want insertion point be 0, 0, 0. We want rotation, just everything 0 across the board, or 1 for scale. And there we go. Right, so it falls right into place. So we've got the kind of going back a little bit. We've got the ReCap Photo, ReCap Pro, InfraWorks, Civil 3D, Revit, all sort of jiving with each other at this point. All right, so let's take, what are we doing on time? We got 10 minutes. All right, cruising through this. Go back to, no, not that one. Back in InfraWorks, we want to pull in our, no, not that one either. Oh boy, getting flustered here. We want to pull in our Revit model. One thing I want to point out though is if you hover over any of these icons, you see this little tooltip that says feature requires you to install Navisworks Manage. If you have, say, 22 for InfraWorks, you want to have Navisworks Manage 22 as well installed. If you don't, what you'll see is these little cloud icons next to some of these commands. So basically what it's going to do with Navis installed and this data import option toggled on, it's going to use Navisworks locally to basically do any of that sort of background conversion that it needs to do. Otherwise, it's uploading to the cloud, downloading it. So that process time could be much longer compared to having, doing it locally. So I just wanted to point that out. If you happen to see those little cloud icons and you're wondering, why is it taking so long to upload this thing and process it? Well, that could be why. All right, not backup. We want Yeah, I don't know that I saved my model, so let me save it. Yep. Yeah. All right. 52, right. Open. Any other questions while this churns in the background here? Now, this isn't uploading to the cloud. I do have Navis installed locally. It's just through the, just the nature of processing the information. So any other questions? We
got an off-topic one. So now Revit, would you be able to use shared coordinates when you bring in the point cloud?
Let's see, is that an option? Point cloud. It is. All right, let's find out. It should work, honestly. No, not the backup folder again. Drop flags. So share. Let's go with this one. Let's see what happens. All right, well, Revit does its thing in the background. Let's jump back over to InfraWorks. So again, we brought in that data source. We need to tell it what it is. All right, so it's buildings, and it's going to be NAD 83, close and refresh. Cool. All right, there it is. So it wasn't set to the correct elevation, obviously. So one thing you want to take a look at, make sure you've got the, oh, look at that, it did. So yeah, just make sure, when you're doing all this, make sure your elevations, your levels in Revit are set. I did kind of gloss over that, kind of speeding through some of this. It's just chugging away right now. So it looks like it did bring in that point cloud in the right location based off of those shared coordinates. It's thinking here. So yeah, as long as everything is set, everything is linked properly. Oh, that's not good. That may have something to do with my building being partially underground there. Right, so we've got all this information. Yeah, look at that. It did actually fall into place. Cool. So we've got all this information tied to each other now, right? So very, very little rework, if any, when it comes to pushing that information from InfraWorks to Civil 3D, or Civil 3D to Revit, or Revit to Civil 3D, or Revit to InfraWorks. You name it. It's fairly seamless. And hopefully, as you saw here, it's actually pretty quick. It's not a lot of hoops to jump through. It's just a matter of knowing some of those add-ins to get the Civil 3D and the Revit in sync with each other. From there, it's just a matter of remembering, okay, I'm using shared coordinates. Shared coordinates is the key for all of these things to fall into place wherever in the world your project is located. Unfortunately, we don't have enough time, but I did want to show some of the format stuff and how we can take all of this and dump it into Navisworks, which is pretty simple once everything is tied into those shared coordinate systems. So yeah, so we're pretty much right on time, right? So okay, I guess we're gonna have a part 2 to this at some point, huh? To get through the rest of it, but hopefully you all enjoyed this and got something out of it.
Let's go back to the slides, please.
Absolutely.
And stay with us, people. So we're gonna wrap up with 2 final slides to give you ways to connect and engage with the Autodesk community. So you can explore the many ways to connect in the Autodesk community, including the global network of user groups in the Autodesk Group Network, our industry-focused communities helping your colleagues solve business challenges together, of course, the Autodesk forums, and staying connected with us on Twitter. Stay with us. You're going to get a survey link. There it is. Kate put it in there. Take a minute right now while you're here and I have your attention. It helps us form and build out our program of Autodesk Community Conversations, how your experience was, what you would like to see it in the future. It really does help inform what we do and to let others know what the impact is. So let's go to the next slide while people are taking the slide or the survey. And I'll thank everybody for attending today. And thank you, Matt. You did it. It was awesome. You danced with chainsaws up in the air, and that's no small feat. Those are all highly memory intensive and CPU and graphics eating machines. So we welcome your feedback, and so please take that survey and continue to stay connected in the Autodesk community, and hope to see you next time. And Matt, there's going to be a next time, right? We got a lot left to do.
Yeah, apparently, yeah. Absolutely. Looking forward to it.
Yeah, thank you. We actually got you, Matt. You got a second?
I do.
We have a couple of things. That the workflow seems to assume the entire project is properly referenced to a standard coordinate system. Often the survey has not tied the site to a state plane system.
Yeah, I don't know how to address that. You know, I've seen plenty of civil drawings that are just sort of randomly started, you know, somewhere close to 0, 0, 0, with no regard, no thought whatsoever put into, you know, well, maybe it should be.
It's a whole new session.
Yeah.
And I will point out that at the link for the session here is there'll be the recording there, but there'll also be a discussion area too. So Matt, if you wanted to post your images that you had, you can do that.
Okay.
So,
perfect. Yeah, perfect.
All right, everybody. I hope you took your surveys. That really does help us. And thanks again, Matt.
Oh, my pleasure.
Thank you, Kate.